All right, we're going to go ahead and cover 3-1, 3-2, and 3-3 all together. They are all on parallel lines, so let's define that. Parallel lines are coplanar lines that do not intersect. So when you have two lines that are going in the same direction and never hit each other, that's what we're talking about with parallel lines. That should be pretty familiar. In coplanar, that just means they're in the same plane. Now this symbol, the two lines, right, like that, sometimes they're a little slanted like that. If they look like parallel lines, that means is parallel to. So if we're looking at this diagram over here, let's give some examples. So I've got AE right here. Which one would be parallel to AE? Which one would not intersect with that? An example would be BF. Okay, so we could say that AE was, and that's a line, was parallel to BF. Now that's actually the only one that is parallel because these ones are on the same plane. Now DH back here and CG, those also wouldn't hit it, but they are not on the same plane. Okay, so another example could be, what about AD and then with BC? So I could use AD, and that is a line, so we give it the correct hat, to BC. Those are some parallel lines. Next, we've got skew lines. S-K-E-W. Skew lines are non-coplanar, so they are not parallel and do not intersect. So that sounds a little weird, but what we're talking about here is, let me erase these lines so we can draw on our picture. We do not want them to be on the same plane, we don't want them to be parallel, and we don't want them to intersect. So an example would be AB here. Okay, AB and CG right here, they are not parallel. They're going in different directions, and with parallel they have to be on the same plane, which those are not. They don't touch any of the same sides of this little cube that's pictured. They are so that covers non-coplanar and not parallel, but they're also not going to intersect because they're just at different places. So that's an example of skew. So AB, line AB, and line CG are skew. All right, and then lastly, we've got parallel planes. They are planes that do not intersect. So when we're talking about planes, we'll talk about a whole side of this cube that is pictured. So let's use ABCD. So with a plane, we only need to label it with 3 letters. So we'll call that ABC is going to be parallel. So I'm talking this whole plane, the whole top. The only plane that that one will not intersect with is the bottom here, EFGH. Okay, so they're going in the same direction and will never intersect. So we can call this EFG if we want, since we only need 3 letters for a plane and we use 2 for lines. All right, so let's look at this figure. Assume that the lines and planes that appear to be parallel are parallel. So which segments would be parallel to AB? Okay, they have to be on the same plane. So what about EF? And these are segments now. And then we'd also have CD. Those are parallel to AB because CD is also on this top plane and EF is on this side plane. So they do share a plane with AB. Now I can't include HG because it doesn't actually share a plane with AB. All right, so which segments are skew to CD? Skew, let's see. CD is right here. We want to be on different planes and not parallel. So first example I see would be AE. We want to go in a different direction and not be on the same plane. I could also use BF, just to name a couple. What are two pairs of parallel planes? Okay, so we could use, there's going to be 3 different ones here, because I could use the top with the bottom. So I could say ABC parallel to EFG. I could also do side with side. So I can call that ABF parallel to CDH. And I could also do front here to the back one there. That would be, let's call that ADH parallel to BCD. Oh, BCG, G down here, okay? So those are the 3 sets of parallel planes. And then, let's go ahead and erase all this so we can see what we're working with for the next problem. All right, what are 2 segments parallel to plane BCGF? So I'm talking about the back of this cube here. Which segments would be parallel? I could use AD would be parallel because it's not going to touch that plane. I could talk about EH. I could actually also talk about AE and DH. So I've got EH, AE, and DH. Those would all be parallel to that plane because they will not touch the plane and never intersect with it, even though all of those 4 are not parallel with each other. Okay, so now a transversal. This is what you are going to see, a picture kind of like this for most stuff we do with chapter 3. All right, so a transversal means this line right here. I'm going to highlight this in pink. Here is your transversal. So this transversal intersects these 2 lines here and here. So the one line that's kind of going in a different direction, that's how you'll always notice that is your transversal. A lot of times I'm going to label this with a 1, 2, 3, 4, 5, 6, 7, and 8. What I'm doing is labeling all the angles in this picture. So, there we go. So we're talking about 4, 6, 3, and 5. These ones right here are called interior angles because they are inside of those blue lines. Then we've got 1, 2, 7, and 8. All are exterior angles. Okay? And that will help you, just to know whether they're interiors or exteriors will help you to classify them, which we're going to start doing on the back. So go ahead and flip your page. All right, so we're going to knock out all 3 sections here and all the things that you need to know. So there are 4 kinds of angles when we talk about parallel lines and transversals. The first one is alternate interior angles. So those are non-adjacent, so not next to each other. They're interior angles, and it even has it in the name, that lie on opposite sides of the transversal. So if you see that word alternate, that means we're going to lie on opposite sides of the transversal. So if we look at this picture, an example of some alternate interiors would be 4 and 6. Because here is my transversal right here. They're on opposite sides of it, but they're also not next to each other. They're kind of diagonal from each other, and that's what we want. So we will have angle 4 and angle 6 is an example of that. Now the other example, the only other two we've got that are alternate interiors are 3 and 5. Again, not next to each other, but interiors and on opposite sides of the transversal. All right, so then if you know that these lines, L and M, are parallel, then we can say that alternate interior angles are congruent. So if the two lines are parallel, remember this is our transversal, then I can say we would have, let me draw these in, 3, 4, 5, and 6 again. All right, so then we would know that angle 4 was congruent to angle 6 because we showed that those were alternate interiors. And then angle 3 is congruent to angle 5 because they're alternate interior angles. And now look at, I've got these markings right here. They're really small, but on that picture, those markings on those lines mean the lines are parallel. So then I can say those angles are congruent. And then the converse of the theorem would say, if I know that alternate interior angles are congruent, then the lines are parallel. Or in symbols, we could write L is parallel to M. Okay, so just the converse, remember we just switch it. The next type of angles we've got are same side interiors. Now, same side interiors kind of give you everything you need to know right in the name. Same side interior angles are interior angles that lie on the same side of the transversal. All right, look at, we've got same side in the definition, we got interior in the definition, which is the name. So, for this one, angles 3 and 6 are on the same side of my transversal line. So angle 3 and angle 6 would be same side interiors. Then the other example would be 4 and 5 are same side interiors. So those are on the same side of my green transversal line, and they're on the inside of the other two. Okay, so again, what you know, if you know the lines are parallel, then with same side interior angles are supplementary. So then I could say, I go ahead and label these again, 3, 4, 5, and 6. Okay, so then angle 3 plus angle 6 needs to equal 180 degrees if those are supplementary. The other example would be then angle 4 plus angle 5 needs to equal 180 degrees if same side interiors are supplementary. So then the converse would be if same side interior angles are supplementary, then L is parallel to M. Then I would know the lines are parallel. It basically just depends on what the question's asking you. And then you'll know which part of this information you need to do or need to use. So then we have corresponding angles. They lie on the same side of the transversal in corresponding positions. So we're actually going to have a lot of pairs for this. So we're looking, if I choose one, I need to choose one on the same side of my transversal. So I need to choose 4, 5, or 8. The one that would be in the same position is 5. So let's do this in pink. All right, 1 and 5 are corresponding. I like to think of it as same seat, different row. So they're both to the left of my transversal, and they're also above the other line. The next set could be 4 and 8. they're both to the left of my transversal, and they're both below the other line. Notice in here we've got one interior and one exterior. We've got, the exterior is angle 1, the interior is angle 5. 4 is an interior, 8 is an exterior. So you kind of get one of each. Let's see, on the other side of my transversal, 2 would go with 6, 2 and 6, and then angle 3 would go with 7. Same seat, different row, you get one interior and one exterior, okay? So what we know about corresponding angles, if those lines are parallel, then corresponding angles are congruent. So I would know that angle 1 is congruent to angle 5, that angle 4 is congruent to angle 8, because I'm reading my pairs from right over here. I would know that angle 2 was congruent to angle 6, and lastly, that angle 3 was congruent to angle 7. Okay? And then the converse of this statement would be if corresponding angles are congruent, then L is parallel to M. And the last type is alternate exteriors. Alternate exterior angles are non-adjacent, so again, not next to each other, exterior angles that lie on opposite sides of the transversal. So very similar to the first one, alternate interiors, except now we want to use ones that are on the outside of my line. So there's my transversal again. If I choose angle 1, I need to hop over my transversal. I don't want to use 2 because it's next to it and they have to be non-adjacent, so I'm going to use 7. So angle 1 and angle 7 would be alternate exteriors. And then 2 and 8 would be alternate exteriors. All right, then what we know about them, if the lines are parallel, then alternate exterior angles are congruent. So I could say that angle 1 is congruent to angle 7 and angle 2 is congruent to angle 8. Okay, and then the converse of that would be if alternate exterior angles are congruent, then L is parallel to M. So alternate exteriors, corresponding, and alternate interiors are all congruent if the lines are parallel. Same side interiors are supplementary. I like to think same side supplementary. It all starts with S. That's a good way to remember it. All right, here's your 3-1 to 3-3. We'll do a lot of practice with this. We're going to spend actually 2 days practicing. So this is your last video before your next test. Make sure you've got this all written down. I'll see you in class next time.